Hello, physical geographers. We are going to talk about landform study in this chapter, really kind of the core of our course. So really we have structure of the Earth's hot interior, crust, the mantle, inner and outer cores, plate tectonics, and structure of Earth. So if you have taken Geography 105 and also and/or 112, you probably have talked about plate tectonics. Composition of Earth, mineral rocks, igneous rocks, sedimentary, metamorphic, the different types of rocks formed through different conditions, the rock cycle, continental ocean floor rocks, um, and so forth. So isostasy, utilizing Earth's mineral resources, study of landforms, critical concepts such as geologic time, internal and external geomorphic processes, uniformitarianism, scale and pattern, example of scale, patterns, and process in geomorphology, evolution of the Earth are all things we're going to talk about. So, structure of the Earth. Most of what is known about the Earth's interior collected by geophysical means, behavior of earthquakes, vibrations, human-made explosions. We see some of that with fracking today. Essentially, especially out in the state of Oklahoma, we see quite a bit of fracking that has caused some tremors on a daily basis. And then we see some natural events like Fujiyama occurred in 2011. We're still trying to deal with nuclear plants and according tsunamis caused by earthquake activity. The Earth's interior temperature and pressure increase with depth inside of the Earth. So think of it in terms of a weight. The more you pile on, the heavier it gets. That's also true with the Earth's atmosphere. So if you go up in the mountains, that's why it's less dense. Warmth is really due to release of energy from decay of radioactive materials. Transfer of heat to interior drives many Earth processes. Internal structure of the Earth consists of 4 shells. We are discussing the 4 layers or shells we talked about. Lithenosphere, relatively thin hard rock upper crust. Asthenosphere, mantles of rocks are more plastic, easily formed. Lower mantle. Below the asthenosphere, even more movement and higher pressure. We talked about it as further we go down into the Earth, higher the pressure. Outer core thought to have molten rock or liquid rock. Inner core, solid, very dense, mass, heavy materials under intense pressure. So we also have the Earth's magnetic field, which coincidentally has been known to change by looking at the crystals that make up the composition of the Earth, mostly rock. The crystals have changed in alignment over many thousands/millions of years, and we know for a fact that the magnetic poles have actually changed over time. For plate tectonics, we see shifting movement of the plates, essentially on the moving over the soft hot asthenosphere. So from the structure of the Earth, now we moved into the composition of Earth, so the various compounds and elements forming minerals. Only 8 elements form more than 98% of mass of the Earth's crust, so it's pretty well defined. 7 principal rock-forming minerals or family silicates combine oxygen and silicon. Oxide combine elements with oxygen. Sulfide, sulfur combine with 1 or more elements. Sulfates, sulfur and oxygen. Carbonates, we have carbon and oxygen. Halides, including salts, and native elements, which basically could be things like precious metals. More details on the composition of the Earth. I would strongly recommend this and several slides afterward. You spend a little bit of time with them, but as a chemical composition, the mineral, and essentially the group. See rocks, their formation and outcrop. Different types of rocks are classed igneous, sedimentary, and metamorphic. Igneous rocks formed by cooling and solidification of molten rock, and we have magma, lava, and pyroclastics. Classifying igneous rocks, chemistry of magma, silicon present, mafic, or felsic. Depending on the amount of silica, and also we use texture. Intrusive igneous rocks or plutonic rock formed cooling below the Earth's surface. Granite, most common texture, often used for different types of features of houses. For instance, countertops, very common. Sometimes flooring and so forth. Basalt, we see some of that in Colorado. Extrusive igneous rocks and volcanic rocks again. It's commonly dark and gray. We see this whole type of rock formed from cooling of lava or bonding pyroclastic materials. Sedimentary rocks are disintegrated into sediment, so it's basically caused by either wind or water, as far as breaking down into smaller pieces and components, as the picture on the right shows. We have essentially sediment can be settled in different strata or horizontal layers. There's different places in Colorado we can go around and see that. And then detroclastic fragments of pre-existing rocks can be used to put together, so essentially almost like cobbled. Organic and petroleum natural gas. I spent a long time with that. Metamorphic rocks, by heat and pressure, chemically active. So essentially we see the pressing occurring down to form rock. So as we go further down into the earth, we see more pressure. Types of metamorphic rock, we have Mount Rushmore as a sample. We also see some in Greenland on the left. Here we can see the rock cycle, energy basically entering into the picture. Sediments, being compressed, metamorphic, igneous, intrusive rocks, basically heating up, extrusive, igneous rocks, basically coming to our surface. We see solar energy fitting into that also. Sample of continental and ocean floor rocks. See the lithosphere and the asthenosphere, some samples in that map. Isostasy, adjustment of Earth's crust due to load atop it. So essentially we have pressure moving the plates downward, essentially causing more force. Topography, surface Earth's configuration, landform, distinct topographic feature. Study characteristics and developments of landforms we call geomorphology, which is really a big focus of this class. Relief, we actually see the change in elevation. We see geomorphic processes, internal and external, occurring within the Earth. So here's some samples of internal and external. I encourage you to spend a little more time with that. Uniformitarianism, process-shaped landscape today, formed by topography of the past, operates slowly, same rate or extent. Geologic time we see in billions of years, where essentially much of what we see today is how the Earth and its crust is formed. Scale tends to be a key aspect in geography. So essentially, what is the extent of the area that's changing? And then geographic study recognizes distribution pattern. We tend to do that in this book quite a bit. We show basically what the theme is in a map throughout the world in the United States. So spend a little time with that. It's pretty interesting. It shows a lot of basically where we have landforms established throughout the world and why they are where they're at.